Okay, so the last of these short lectures for today, we're going to be taking the sequence stratigraphic models we talked about earlier, notwithstanding their limitations, and we're going to use them in a predictive sense to think about exploration plays. So we're back to this model, a model for a basin with a shelf, a slope, a basin floor configuration, and you've already seen this model before, so I won't labour the point by repeating information about it now. So let's start off with the falling stage systems tract. So remember, that's characterised by development of an unconformity on the shelf, bypass of sediment down the slope, and deposition of sandy basin floor fans. So these basin floor fans can have excellent porosity and permeability. That obviously depends on exactly what the composition of the sand is, where it's coming from. So assuming here we're dealing with quartz-rich sand. These basin floor fans have a high lateral continuity. They have a mounded topography on the seafloor, although that, the degree to which that is evident in seismic data is quite variable. So in terms of trap configuration, well, we're really relying on here on a stratigraphic trap, both up dip pinch outs, down dip pinch outs, and also lateral pinch outs, which are into and out of the plane of this cross section. Those stratigraphic traps can be enhanced structurally. For example, we can have differential compaction of fine-grained mudstones around the sandy fan, and that can exaggerate the original stratigraphic trap geometries. Okay, the source rocks here. Well, source rocks, we're really relying on a source and the migration from a deeper stratigraphic level. The condensed shales in the dark green in here, they have the potential to be source rocks that would require lateral migration. More commonly, migration is from an underlying older source. Probably the biggest issue here is with the seal. So, there's always an issue about the up-dip seal. Is any component of this basin floor fan linked through sand up a canyon fill, for example, to shallower stratigraphic levels? Are there any sandstones or siltstones in the overlying mudstones which would allow upward escape of hydrocarbons? So seal is a major problem with basin floor fans. Okay, we can now move up to thinking about the Lowstand fans. So at this stage, we've re-established deposition within valleys at the shelf edge, and we also have a mixture of sandy and silty deposits on the slope itself as a slope fan. So the reservoir, these slope fans do have reservoir potential, not as good as the basin floor fans. So typically sand bodies in here, many of them are channelized, they're relatively sinuous and a variable connectivity. So they're smaller and less well connected than the basin floor fans. In terms of trap style, we're also thinking about stratigraphic pinch outs. It's also important in here. Those pinch outs, they can be exaggerated if there's some structure associated with the slope. That could be, for example, in basins in which there's a mobile salt or mobile shale in the underlying section. That can cause depositional topography and compartmentalization of the slope, which can lead to ponding of reservoir bodies. We'll discuss that in more detail when we think about slope systems, deep water systems, in a couple of days. The source rock, well, again, we're thinking really about source rocks being in older, deeper sections and then migration vertically up into these units. There's also the potential for condensed mudstones, these dark green colors, to provide, those potentially have source potential if we have lateral migration. The seal in here, well, actually these mudstones, these condensed mudstones, they're typically rich in clay. So those have the potential to be good top seals. And of course, any sandstones in the slope can also be sealed by finer grained rocks immediately around them in the slope, in these slope fan systems. Okay, another part of a Lowstand systems tract are the valleys and then these shorelines at the shelf edge. So this is referred to as the prograding wedge of the Lowstand systems tract. So we have reservoir potential both in those shelf or shallow marine sand bodies and also within valley fills themselves. Okay, traps in here. Well, there's a stratigraphic component. These sandstones pinch out in a down dip direction, in particular into slope deposits. They can also pinch out in an up dip direction, but that really depends on what underlies the unconformities of sequence boundary here. In basins with a shelf slope basin floor geometry, particularly those associated with major deltas, there's also common structural features. So growth faults, for example, as shown in here. Those faults are triggered by deposition at the shelf edge, and obviously they introduce the potential to seal, to have structural seals for those shelf edge sandstones against mudstone intervals. So I know we're inferring structure here, but it's linked to the stratigraphic setting. Okay, the source and migration, well, again, that can be from older, deeper stratigraphic levels, or from these condensed shales, which you can see, again, these dark green colors. They're juxtaposed against these shallow marine deposits of the Lowstand wedge, and they also provide the potential for good top seals as well. Okay, now let's sort of focus on the transgressive systems tract. So the transgressive systems tract is partly represented by these backstepping or retrogradational shallow marine units. Also part of the valley fill is typically transgressive. So you can get thick sandstones, but of only localized extent within the valleys. Those sandstones will be missing and absent outside of the valleys. These overlying sandstones, the shoreline sandstones retreating outside of the valleys, are typically pretty thin. So they can have good reservoir properties, but typically small volumes. Traps, well, we're thinking about stratigraphic traps, either within valleys. If the underlying rocks are muddy and the rocks to the sides of the valley are muddy, then the valley can be stratigraphically trapped and isolated. Also, these shallow marine sandstones developed during transgression, again, those can be isolated from each other and enclosed in mudstones. Again, this really depends on the lithologies that underlie the sequence boundary. If these are juxtaposed against highstand or falling stage systems tract sandstones, then obviously that means there isn't a bottom seal to those units. Okay, source and migration. Well, in this case, the obvious source is within these condensed marine shales in the dark green in here. They juxtapose with and they interfinger with these transgressive systems tract deposits. Also within estuaries, we can develop local lagoons, and those lagoons can also generate good source rocks as well. And in this case, the top seal is provided by these condensed marine shales. Again, those are the dark green ones. Okay, so then we're looking at the overlying highstand systems tracts, and those would also continue into falling stage systems tract deposits, shallow marine deposits, which might underlie and extend beneath the sequence boundary. So the reservoirs in here, they're dominated by shallow marine, and deltaic is a subset of shallow marine sandstones in this context. Those can have excellent reservoir properties, and obviously they can be stacked vertically and also stacked laterally within highstand and falling stage systems tracts. However, what's missing here is a trap configuration. Although these shales do pinch out, although these sand bodies do pinch out into coastal plain deposits, those coastal plain deposits will be a mixture of shales, but also sandstones. These units also pinch out in a seaward direction into offshore shales, although again, that's a gradual change from sandstone to silt to clay as we move progressively offshore. So predominantly we're thinking about structural traps in here, not purely stratigraphic traps. Okay, in terms of source rock and migration, well, we can rely on our old friend of having source rocks and migration from deeper stratigraphic levels. We can also get gas associated with coals, for example, in a coastal plain succession. So we can also get migration laterally from coastal plain into these shallow marine sandstones. I've mentioned already that seals and traps are the major problems in here. Flooding surfaces associated with individual parasequences, so that would be represented by these individual sort of zigzags within these series of stacked sand bodies. They can provide local seals, but they will not provide seals for a number of these vertically stacked units. So we're really relying on broader seal and trap configurations. Okay, so that gives you a little sense about how the sequence stratigraphic models have been used in a predictive sense for exploration. Let's say a little bit more about how successful that's been. So what I'm looking at here is something called a creaming curve. That you may have come across this before. The vertical axis is the cumulative discovered hydrocarbon volume, and the horizontal axis is in time or the number of wells drilled. So we start on the left, and before any exploration, as we move towards the right, we have an increased amount of exploration expressed in time or in wells drilled. And typically, in a typical basin, what we'll find is that early on in a basin's history, we find a number of big fields. So we add a large accumulated volume of hydrocarbons for a relatively small amount of exploration time or a relatively small number of exploration wells. That's the cream of the basin. And as we go further into the basin's exploration history, what we'll find is we add smaller volumes, but the rate of which we add accumulations decreases through time or with the number of wells. So typically we see a curve with a steep rate to begin with, and then a falling rate and reaching a plateau when the play is effectively being fully explored. So this curve is sometimes referred to as a creaming curve because this is the cream in the early part of a basin history. So if you think about that idea in the context of, again, of these sequence stratigraphic models, this is how they might be expressed. So again, hydrocarbon volume discovered in the vertical axis from 0 up towards the full potential realized for the basin, and then time or number of wells drilled from the beginning through to the end of the play life. So early on, typically it's the big structures that are drilled, and those relate to the Highstand and falling stage systems tracts. We're really relying on structural trap configurations in here. Then in a later part of field life, we might be looking at basically transgressive systems tracts. So we recognize there are sequence boundaries in the shallower part of the section, for example, and we think about developing models around those. And in those cases, it's the sealing potential associated with the rocks around those sequence boundaries on the shelf or the shallow marine part of the section, which is the critical risk. And then in the later parts of the basin life, we might consciously explore for deep water fans, so down dip of those sequence boundaries. And there, well, the seal is a risk, but also the source rock. Once we're into the deeper part of the basin or deeper part of the stratigraphy, we're away from the typical source rocks that supply Highstand and transgressive systems tracts. So if you like, is a bit of a cartoon concept. Let me show you an example. This one is from the Gulf of Mexico. Offshore Gulf of Mexico, the southern US. Again, hydrocarbon volume increasing from bottom to the top, and then time increasing from left to right. And the pink curves in here, well, they represent shallow marine deposits on the shelf. So really the Highstand systems tracts. And that was where most of the exploration was focused. Lots of early big discoveries, and then that play basically reaches a plateau and is sort of exhausted. In this case, there's a little bit of hydrocarbons added in the Transgressive systems tract, but most of the recent, and by recent I mean sort of mid-80s through to the present day, most of the additions over that time period in this basin have been through exploring for basin floor fans in deep water. So really the low stand systems tracts and falling stage systems tracts on the basin floor. Okay, I'm going to stop there, and then we're going to meet up with live and talk through an exercise.